Hi everyone, Brian here from Elektor. Today we're diving into something big. It's AI moving out of the cloud and into the physical world. So our show is called The Future of Physical AI with Edge Impulse. We're talking robots, cars, sensors, and other everyday devices. And Edge AI is changing the way engineers think about intelligence, and it's happening faster than most people realized. So joining me today is Daniel Situnayake, Director of Applied Research and Edge AI at Edge Impulse, and one of the founding engineers behind the platform. Daniel, how are you doing?
Hey, very good. Thanks, Brian. How are you?
Good, thank you. I hope I didn't butcher your surname too much.
No, perfect.
So Daniel's on the east coast of the US where it's 10 a.m. and in Central Europe it's 4 p.m. and here in South Africa it's 5 p.m. And I see we've got people joining us from all around the world: Spain, France, Belgium, Poland, Italy. So far we're in Europe. Okay, there's Rio de Janeiro, Arizona, USA, Black Forest in Germany. Okay, so I could go on all day. It's a very popular stream. So Dan, you've got a wide audience watching.
Fantastic.
We tell you more about Dan. He is a very busy man, so this could be long, but I just want to say that before Edge Impulse, he worked at Google Brain on TensorFlow Lite and Dialogflow, helping developers bring machine learning onto phones, microcontrollers, and specialized system on chips. He's also the co-author of TinyML and AI at the Edge, two of the core books that shaped the embedded AI community. And Dan's background stretches from full stack engineering to custom sensor hardware, data science infrastructure, and even leading an agricultural tech startup focused on sustainable protein production, if you can believe that. He's also been an educator at Birmingham City University and Hack Reactor. So today, Edge Impulse acts as part of Qualcomm, which we know has been very busy. For example, they've just acquired Arduino, and there's their Arduino Uno Q that just came out, which I'm having fun with at the moment. And Dan's work at Edge Impulse sits right at the intersection of advanced edge hardware and the next generation of on-device intelligence. In short, he spent his career making intelligence practical, accessible, and useful in the physical world. Now, the reason we've got Dan on today specifically, not just because he's an expert, is because of our special edition that I want to spotlight for you. It's Elektor's brand new 2025 guest edition. It's guest edited by Edge Impulse, and it's out now. And it's honestly one of the best Edge AI resources you'll find this year or next year going into 2026. It's packed with real buildable projects, motion recognition, keyword detection, keyword spotting, object detection, vision language models, power optimization on battery-driven vehicles and devices, and of course, contributions from the Edge Impulse team, many of them including a great piece from Dan himself. That's this article with that handsome man right there. And just want to tell you that our giveaway today will be 5 of these. We're giving away 5 free copies of this edition, which you will read all throughout next year. And as always, the code word will give you halfway through the episode. But let's move on with the show. So back to Dan. Let's start with your article in this edition, your Tech the Future feature. You paint a picture of AI leaving data centers and embedding itself onto physical devices in the physical world, in robots, appliances, industrial systems, and everything. So how have you seen that shift taking place over the last few years?
Yeah, so it's really interesting, Brian. I think both of us are old enough to remember back when everything wasn't happening in the cloud. So it's interesting today we talk about AI and computing, and we sort of have this assumption that like all this work is going on in the cloud and it's coming down to the edge. But really, I see it as this like tug of war between the cloud and the edge that's been happening since the dawn of computing. You have these centralized big computers, and then we had mainframes, and then thin clients, and then thick clients, and the kind of rubber band has been going from one end to the other, back and forth. And recently, with this whole big boom in AI, there's been all these new models, all these capabilities, and because it's been so sort of useful to train models in distributed cloud infrastructure across lots of GPUs and so on, we have this association of data centers with AI. But really, two important things to think about there. One of them is that just because it's useful to train something somewhere doesn't mean that's the right place to run it in production. And there are so many incredible, compelling reasons why it makes more sense to actually run AI models at the edge. Things like latency, um, energy consumption, not having to send things on a round trip to the cloud all the time to get results, security, privacy. So that's kind of the one thing there. And secondly, we've now got all this hardware at the edge that is really, really capable and actually can run some quite powerful models at high speed, high enough speed to do really useful things. So we're moving from this world of like an assumption that everything's going to be happening off in the data center somewhere, and your device is very simple and just connects via API and sends data back and forth. Um, that's kind of the old concept now, and we're moving towards a world where we have things running on the edge. Yeah, sure, have some big models in the cloud that they can call out to for certain things, but we're going to see more and more. It makes so much sense to have this intelligence at the edge, and there's so many applications where that's required. If we think about a self-driving car is, my favorite example for this, because you don't want your car to suddenly you lose the ability to drive because the internet connection goes down. That's just not going to fly, right? Like you're going to run someone over. So there are so many applications like that where there's a really, really compelling reason that means that compute has to happen at the edge, and you can't really do the thing without that. So I'm really excited for the kind of explosion we're going to see in use cases that are enabled by this.
Great. And I liked one of your metaphors that you used in the article. It was the Cambrian explosion. For our audience, life originated on Earth like 3.8 billion years ago. And for more than 3,000 million years, it was just very simple, very quiet life under the ocean. And suddenly about 500 million years ago, boom, there was a great explosion of life called the Cambrian explosion. So that metaphor lands well with me. In biological terms, it happens when constraints fall away and capabilities suddenly take off. So what constraints in robotics have just lifted? What mutations, so to speak, are enabling this rapid diversification?
Yeah, that's a really good question. And I think it's in a few different areas. So I think, if I go back like 6, 7 years ago when I first started working on this stuff and thinking about it, the real thing was like, we've got these microcontrollers which were designed for like signal processing, and just being able to render graphics for stuff, or just stuff that's a little bit more power hungry than your very basic applications. And so the hardware was there, and certain people like Pete Warden, for example, who I used to work with at Google, started thinking about, wait a minute, we've got these really capable general purpose processors. Actually, some of them have like stuff for accelerating linear algebra as well on the chip for DSP. What if we used these to run some machine learning models that were, starting to get impressive at the time in terms of doing things like computer vision with a relatively small model size? And so folks like Pete started thinking about, hey, what if we could run these relatively big models on this relatively powerful hardware? And it was really like this kind of world that existed out there of compute capability that no one had tried to run these workloads on before. And turns out it actually works really well and isn't even that hard to do. So we started to get people exploring computer vision on microcontrollers, for example, and getting like almost real-time frame rates, allowing you to do really genuinely useful stuff. Before, it had been just the domain of like big tech. So for years, you'd have things like deep learning powered wake word recognition in cell phones, but it would take a team of like hundreds of people to figure out how to do that. And we got to this point where the tools in machine learning for easily training models and the availability of data sets as well, which is equally important, came together to make the model side more accessible. And then we had the hardware that was, there with this latent capability that hadn't been fully made use of for this purpose yet. So that's what kind of kicked off this initial thing. And then as industry has realized the potential, and again, it's, you know, down to people who've had this vision from early on and set up things like the Edge AI Foundation and started working with it in companies to advocate for more research and development. We've seen both sides of that really take off. So on the software side with the modeling, we've got tools like Edge Impulse and other tools like ours, which make it much, much easier to collect data and train models and test them and make sure they actually work. So you've got these models that do really good things. You've even got like companies that are training big generative AI models and thinking about, okay, what happens if we try and make these smaller and smaller instead of just infinitely bigger and bigger? And then at the same time, all of the companies developing silicon have realized, oh, wow, actually, you know, it was just kind of by accident that some of these high-end MCUs were capable of doing this. What if we start designing silicon specifically to be good at running deep learning models? And even to the point of like different families of architecture, like convolutional models or transformer models. What if we have silicon that can specifically accelerate the math that they use so that the most popular types of models run really fast on the hardware? So once that kind of caught on, we've just had this crazy growth of like, there's hardware coming out, you know, year on year, more and more powerful. We're at the point where we're able to run genuine like large language models on fairly low power devices very quickly, for things like multimodal inference. So you're not just taking in text and outputting text, but you're taking in text, audio, video. We've then got, you know, at the smaller end, the models have got more and more efficient. The capabilities, the hardware to run bigger models very fast with unbelievably low power is amazing. So, you know, something that would have been running at a few frames per second a few years ago on something that's like moderately low power can now run 30 frames per second on something really low power. So it's like at both ends, we're getting more capability to run bigger models faster and, you know, do things we just couldn't do before. And at the low end, it's like you've got cheaper hardware and lower energy consumption hardware that can do more and more and more. So that's what's kicked off this explosion where it's like it opens up this whole landscape where people who are innovating in the application space, so they're thinking like, hey, what kind of new products can I build? What kind of cool projects can I make? You know, from industry through to like art, we're seeing people realize, hey, I can actually do this now. I can do person detection in real time on an ultra low power, low cost microcontroller that sits in the field for like years on a single cheap battery. And we've got people deploying these out in the jungle looking for wild animals that are like being protected. We've got people deploying this stuff in factories for health and safety. And then there's like the high end where we're only just starting to see the capabilities and potential of these generative models. And that's even, you know, barely been thought about. I think that the public consciousness of what can be done on edge hardware is almost, you know, it's like in an infant stage. So we're really in the early stages of this Cambrian explosion as well. It's like it's only just kicking off. So very exciting.
And are you afraid of the future? Unintended consequences?
If it wasn't for this, I kind of would be, because I find AI fascinating. You know, it's what I do for my job, and you know, I think like a lot of this stuff's really cool in theory, but then if we talk about the future that's been painted over the last couple of years with big AI companies and stuff happening in the cloud, the idea that you've got these giant models that are completely closed source, living in data centers, slurping up all of our information, and everything we do and everything we say and all our work and all our personal life is mediated through these few big companies that have these big models in the cloud. I don't like that at all. You know, I really value privacy. I really value extensibility and hackability, and you know, being able to reach in and modify things and understand what's going on under the hood. And the thing that's really reassuring to me about the future we have with Edge AI is that you can have the same capabilities you have in the cloud running on hardware that you own, you control, you can work on, you can change. that to me is really like what we need for this to be an exciting and fair and equitable and open future versus this sort of a little bit nightmarish idea of everything is just controlled by a few big companies. So I think it actually is this big opportunity for things to get distributed back into the world. And it's like I said about the tug of war between cloud and edge. Things are tugging back to the edge. I don't think these cloud guys know that yet. I don't think they've realized. And I think a lot of this assumption around like we're building so many data centers now because we have this assumption that all the AI inference is going to be happening in data centers. But model improvements are plateauing. That means, models aren't making the models bigger isn't making them that much better anymore. And once the models stay the same for a while, the companies making the silicon can just dedicate a ton of resources to optimizing those model architectures. And that just makes the cost per inference, the cost of the silicon, the energy consumption go down and down and down. So we're going to see a point where, maybe the biggest, craziest models have to run on a big GPU, but most things are going to run on hardware that's a lot more within reach, and it doesn't have to live in a data center. So I'm quite optimistic about that. And I think, for that to work, we also have to have like open weights models, which is also very important to me. So I feel optimistic about how things are going to go. I don't think it's necessarily going the way that everyone assumes.
Well, that's a good point. I mean, back in the 80s, as they say, we used to buy devices that you bought them once, they had the firmware on them, and that's it. You owned it. You could take it apart. You never got pushed a firmware update. But nowadays, you got vehicle companies wanting to sell you a subscription so you can use the heated seats. So I'm a big fan of owning your own devices and getting in there and open source and so on. If I can take you to this quote here from your article that I liked, we are beginning to build embodied AI devices that have general understanding of the principles of the world. Now, when you say embodied AI devices, do you mean that the small edge AI devices can have a general understanding of the world?
So yeah, I think that quote is like best to think of a kind of a metaphor because AI doesn't have an understanding of anything, right? It's like a bunch of numbers in a big matrix that we do multiplications and additions on and put an input in and something comes out. Like AI doesn't really understand things, but what it does is model things. And so that, that's why we call a model is because it's basically meant to be a sort of mathematical representation of the training data that it was trained on in some way. And the relationships between things in that training data get modeled as numbers in the model, and then you can use the model to make predictions on stuff. And even these big Gen AI models are just the same thing. So the thing that's crazy about them is you can feed in all of the text that we have ever created on the internet and all of the images that have ever created on the internet. And while we're training the model, and then you get a model that has built up all these associations between concepts that actually are relevant to things in the real world. So it kind of understands, like, I don't know, that like what is a person, what is a house, what is a car, and then more sort of complex situations. It can potentially like make associations between things and figure out what to do in a given situation. So when we apply that to edge AI, I like to think of intelligence in the AI at the Edge book. We try to define these things because they're very hard to define, and you really need to be a philosopher, and I'm not. But defining intelligence as the ability to make the right decision at the right time is a good kind of broad little mini definition for our purposes. So if we're trying to make an intelligent machine, that means it's a machine that, given certain inputs, is more likely than not to give the right output. And that's what we're going to be able to build with this type of intelligence on device. So at the beginning, it could be very simple. So we've got like a little microcontroller doing person detection that can sit in your doorbell, so that when the delivery man comes and puts down a package, it sends you a notification, and it can do that on the device without having to like send all of your pictures from your doorbell up into the cloud. So that's like the most easy mode version of that. But then you can get more complicated. So, think about like a self-driving car again. Like a self-driving car is basically a bunch of models and a bunch of sensors, and the sensor data is coming in through the models. The models sort of trying to make sense of like what's going on in the world. You have different kinds of models for different sensors, maybe, or you can just have one big model that ingests it all. But what it's spitting out is like control signals for like how to turn the wheel and how to accelerate and put on the brakes. And so that's just another example of intelligence. It's like making the right decisions at the right time. And so that's this kind of embodied physical intelligence that's making decisions in the world and navigating the world. And self-driving cars are just such an obvious economic thing, that, you know, it's very appealing. It's got an obvious market. So companies have been working on that for ages. But every single industry, every single hobby, every single human activity has opportunities where, hey, if we could put a bit of intelligence in some kind of device and you know, use it here, it could be helpful. So for example, imagine like a factory where we've got a production line, there's stuff whizzing past. Sometimes something isn't manufactured properly, and maybe it's because like the machine's breaking or something. If we can spot that early and slow down the machine and call someone in to have a look, maybe we can save something getting really broken and having to stop the line for hours. So what if we have a device that can do that? And it's all running on the device. It's been designed by the people who work at the place using tools that are accessible to regular people. And they're able to create these models that live on the device that help it interpret the data coming in and then act on the machinery to slow it down so someone can come and inspect it. That's just another example of that. And then going out, you know, into the far future, things can get really crazy, and we've got all sorts of stuff being controlled by AI. But the underlying premise is the same. It's like people can kind of teach this thing to do something and make intelligent decisions, and then it's like one less thing that you have to think about, so you can focus on doing your job better. And you've got these little helpers and assistants that live in the physical world.
Well, you do make great metaphors, I must say that about you, Daniel. One thing I liked is when I discovered artificial life. I mean, I was used to plotting sine waves and, you know, tangents on computers. They were always predictable. And then I discovered these things in books that very simple rules on each of them. But when you put them all together, they can do amazing things. You can build worlds with them. And you worked with tiny farms, which I believe was ants. And I'm also in crickets. Okay. I'm also an Edward O. Wilson fan, and I loved his writings on insects, mostly ants, but crickets as well sometimes. And then you use the metaphor of an enchanted forest. So that's devices behaving more like an ecosystem of organisms, small edge devices with not a heck of a lot of power like your big GPUs, but together, working together, acting locally, reasoning locally, but interacting. So what still needs to happen to see the magic of the enchanted forest happen?
Yeah, so I love this question. And, you know, I'm also a big fan of stuff like Conway's Game of Life, where we've got this emergent kind of behavior and patterns that come out of all these simple rules and things working together. And, you know, that's the world we live in to some degree as well. You know, we all have these rules that we operate by, we have systems, and everything kind of works together, and we get these emergent phenomena like industry and culture and art and science and you know, relationships. And I think there's this one view of the world, like where we're headed in history, where more and more of this stuff becomes the domain of big AI models that are running in the cloud, and they're like these monolithic things. I find that slightly, you know, horrifying. I think what we want to be building is a world where this extra intelligence that we're capable of and these extra insights and things like that exist at a human level and exist around us and help us with our day-to-day lives. And they're simple and small and fit in and collaborate with what we're doing already. So good examples of that is like, I gave that example of a you know, industrial workplace where the tools exist for the people who work there to build some tool that helps them automate a part of their work which is tedious or difficult or dangerous. like this example with monitoring stuff on a production line. If we give people the tools to create these things that are useful for themselves, then we're going to have this Cambrian explosion of loads of little things that wouldn't be feasible for one big company to solve. And so what I think is we're going to see more and more of these things cropping up throughout our homes, throughout our workplaces, these bespoke little solutions that can help us in some way with intelligence. And it's people like the Elektor community who are going to be building that stuff. And where I think of this idea of the enchanted forest, it's like this idea that's in so many different cultures of like this kind of like animistic world where everything is a little bit alive and a little bit aware and a little bit enchanted, and you're like walking through the woods and the trees are aware of you, and the forest is providing you with food and with shelter, and we're living in this world that sort of we're ecologically part of as a system. And the thing that we've got kind of abstracted away from that as human beings living in the kind of modern way we do. And I think some of this technology weirdly gives us the opportunity to go back closer to that world, where we have a world that's responsive to us, where it's designed for us to fit in with, and isn't just mediated through these giant companies. So I think that's very exciting to me. I think, the opportunity to build this type of technology where we have processes going on that are defined by us through hardware that we've built for things that we want to do is very compelling. And there's this every time there's a new era in technology, it creates new opportunities to define how things are going forward. If you think about like mobile technology or the web or computers, or all the way back. So now we've got this moment where we can create this new world of technologies that are small, simple, responsive, work well together. A kind of example of this I like, that's like pop culture, is you can tell I'm like a Star Wars fan because I got some pictures on the wall. But if you think of like Star Wars droids, they're not like a giant brain living in the cloud that's like godlike intelligence that controls the whole world and your whole life. In Star Wars, they have these little robots that do one task, and they're really friendly, and they just live in the background, buzzing around, doing kind of ecosystem services, like things do in nature. And I think that's a much more healthy, much nicer, and more realistic model for the way that we live with advanced AI technology than having these giant things in the cloud that none of us have individually created, and that are sort of running everything under the same kind of gamut.
So less of a Death Star and more of a Wall-E.
Exactly.
So I'm glad you mentioned the Elektor community, because we've got questions coming in, which we'll take questions after the webinar. So please drop them in the chat. Now, in the addition, you mentioned that even a 512 kilobyte microcontroller can now run keyword spot, which is almost hard to believe, and basic vision models. What does that mean for people building low power or legacy hardware products?
Yeah, really good question. So, I mean, I think I gave an example earlier of like we have a bunch of people using our platform to build stuff for conservation. So like camera traps is a really big one, where you've got like a camera set up in the forest somewhere, and you want to try and understand the population of certain species of animal. And the traditional way these works is you have like infrared trigger, that whenever there's movement, it will take a photo, and then it fills up an SD card, and someone has to go out hiking in the forest and get the SD card eventually when it fills up. The problem there obviously is like every time the wind blows or like a hiker walks past, the thing's going to be triggered. But maybe you're looking out for a certain type of animal, and you only really care about that. So now what these researchers are able to do is build these devices, but they have a little bit of AI built in. Maybe they don't even have to change the hardware that's on there, because these models can run in such constrained hardware. But the model itself is actually looking like when the infrared sensor triggers, the picture gets snapped, the model wakes up. It's like, is this the certain species I'm looking for? if it's not, it just throws the image away, and if it is, it saves it. And so that's great. The camera, the flash card is filling up much slower. But the even cooler thing you can do then is, if you actually just care about a count of how many animals I've detected, you can do stuff like hook this camera trap up to a low power satellite thing, like a kind of satellite LoRa thing. I've done some experimentation with. It's really fun. Every time the satellite comes over, you can just send a few packets, but it's enough to send a count of how many lions, did I see today? How many of this endangered shrew came past my camera? And that's all you need. And now this thing can live out in the field for 5 years on the same battery charge. You don't have to pay someone or pay for flights and this big expedition to go out and get the thing every time the thing fills up. So it means these researchers can do way more with the budget that they have, and across a much broader area. And that gives us way more insight into the way that these ecologies are functioning. So it's just that kind of thing repeated in every industry, in every field, from science, engineering, industrial production, agriculture. We're seeing that you can measure more, you can understand more of what's going on, and it's costing less, and the hardware is cheaper, and it lasts longer, and there's less like tedious involvement of people having to go out somewhere and check something, or burn a load of gas driving out into the desert to check the sensor on an oil well, or this or that. So it's just kind of a huge boon for all of these different things. And it's one of the ways where, we talked about the Cambrian explosion, where you've got all these different possibilities suddenly opening because constraints have gone down. And this is one of the constraints. It's like we're removing constraints around cost and around friction and convenience. So like what we can realistically do at this stage is, on like a high power microcontroller or a mid-range microcontroller, you can do object detection. So we're taking a picture and finding all the instances of a certain object in there. So the object could be a person, or a tiger, or it could be a car. And you can really understand what's going on in that. From those inferences, you can do things like counting traffic. Like if you draw a line along the screen, imagine there's a line here, and you're like, how many people are passing that line? Maybe you're trying to count how many people have come into my shop, or how many people are walking down this busy road. Whenever the person crosses the line, you just have a little if statement saying, if the person has crossed the line, add 1 to the counter. Really simple logic, and then you can do stuff with that numbers at the application level. So it's all quite simple. You've got the models are either like pre-trained, sometimes like a person detection model, but a lot of the time they're custom to a particular use case. And you've got tools like Edge Impulse, which you can use to upload a load of data about your particular use case and train a model that works specifically for you. So like these models with the animals, it's like you're not going to find one model that has like every animal in there. You're going to get a data set of the animal you care about, train a model that works specifically for that. And that way the model can be really small and really efficient because it's focused on just one thing. And then you deploy that in your device. So it's pretty easy in a way. It's definitely not easy to design a whole product end to end around this and make sure it works well and works fairly across different populations of people, and is designed well. And building things is hard, but the ML piece is relatively well defined and simple now because of the tools that have been developed, and that's a huge change from where we were a few years ago.
Well, that is quite amazing. I mean, coming from someone who used to work for a company back in the 90s who would record the 8-hour shift on VHS tape, and then they would pay retirees to sit through it to spot any suspicious behavior. And then later on, we had motion detection, so you only record when there's movement. And now you can say, okay, 500 animals passed by the camera, but only 3 of them were mountain lions. So that is quite amazing, really empowering.
Yeah, this is that example. Like it's the same exact thing I heard from some people I've worked with before at like a agricultural research group, and they were basically having volunteers sit in a chair and watch cows. They wanted to understand how often is the cow eating versus walking around, because the more time the cow is eating, the more the cow is going to grow. Um, and so they literally have people sitting in, folding chairs out in the field, timing how long the cow is eating. And it's just completely crazy. And so obviously you can only really do that with like a few cows. Whereas with this type of technology, it's something you can do across your whole farm without any, um, you know, real constraint other than designing and building the thing in the first place.
Awesome. I'm going to interrupt briefly before I move on because I want to get to our giveaway, which I said earlier. We will tell you the code word. We are giving away 5 of these awesome special editions, guest edited by Edge Impulse, as you see on the cover there. So let me give you the code word. Here's the entry form. The code word, I didn't want to be too obvious, so just Impulse, not Edge Impulse. So there's the URL on the screen. Go and enter, and good luck at winning one of these amazing Edge Impulse editions. 124 pages of pure gold. And yes, I'm monitoring your questions. If you see my eyes darting around, I see the questions coming in. I just have a few more questions of my own for Daniel. So let's talk Qualcomm. The acquisition by Qualcomm, that's a huge milestone. Mm-hmm. And from an engineer's point of view, what new capabilities or tooling does this unlock? Does it accelerate the move toward bigger models running at the edge?
Yeah, it's been really exciting for us because, I mean, the first thing is that it just gives us this big platform where we have really ambitious goals, and we always have at Edge Impulse, about enabling everyone in the electronics world, in the ML world, in the programming world, more generally, to be able to build stuff using Edge AI. And part of that for us is like having the reach to be able to reach as many people as possible. And so being part of Qualcomm has just given us this huge remit to like grow our community, provide more free resources, do more teaching. We've got amazing other kind of compatriots within Qualcomm now, like Arduino. Who thought we're going to be able to work so closely, collaborate with such an incredible company that's been like a part of my journey in embedded development since the very beginning of my career. So just this ability to kind of do things at scale and collaborate is so amazing. And Qualcomm's been very, very careful to protect our sort of unique thing, which is that we've always been agnostic across all hardware. We want people to be able to build stuff from the smallest hardware to the biggest. And all of that isn't just going to come from one company. It has to be from this huge ecosystem of different companies, from startups to other big silicon companies. And Qualcomm sees that vision and recognizes that is like what we need to do to succeed. So it's just kind of going to be, from our point of view, in terms of Edge Impulse, just this huge opportunity to go bigger and give even more. And what that means in terms of technology and engineering is like making it easier to train more models and different types of models. One of the big projects Qualcomm was very excited to encourage us to get rolling on when we joined was what can we do with vision language models on the edge? So imagine a model that's like a few hundred megabytes, and it can take images and text as input, and then it gives text as output. So this is something that people start to experiment with in the edge space, and there are increasingly lots and lots of different examples of hardware. Like Qualcomm has this like IQ9 hardware, which is able to run these models very fast. So, and there's tons from other places in the industry as well. So what does it take to turn this interesting capability, like a science experiment or a hobby project? Can we run this model on this device? Going from that to being like an actual engineering tool that you can be confident in deploying in production is a big journey. And so we've been taking that journey so that we can provide that for the community to use. So what we're going to be launching pretty soon is a set of tools that let you use a VLM model for zero-shot image classification. So the idea is that instead of needing a giant data set of things, you can use this model's innate knowledge about the world to just give a description of something, and then the model can recognize it in an image, and it will give you the outputs of that in a structured way that you can use in a computer program. So for example, I could say like, tell me, if there's a red car, tell me there's a red car. If there's a blue car, tell me there's a blue car. And it knows what a car is, and it knows what blue and red are, so it can do that. But because it's one of these Gen AI, fancy models, it can do a bit of reasoning as well. So I could say like, tell me when it looks like there's a dangerously driven car, and we're feeding in some things, and it looks like they're going across the line in the middle of the road, and maybe that gets flagged as dangerous driving. Or we could say, tell me when there's a really cool car, and it like kind of knows like what would you think of cool. I don't know, that's a very ill-defined concept, but this model will take a guess at it, and it can give you a count, or tell you every time a car that's cool's gone past. If you've got a particular opinion, like, oh, I really like old Porsches, then it's going to tell you every time one of those went past. Obviously, that's a silly example, but for people who are working, trying to rapidly build useful stuff in industry, that's really, really helpful, because you can just quickly try something out, typing in a prompt and find out, does this image match the prompt? Then it's going to run on device. And once you've deployed it to the device, you don't have to think about it as a language model, this or that, It's just a very simple like component, basically, where the image comes in from the camera, and then some like structured data comes out in your C++ library that's telling you what's in there. The thing that we've built around that is a set of tooling for testing that it actually works. So you bring in a real test data set of real examples of stuff that you've labeled, and then you can try out your prompt, and we'll tell you how well did this do on your test data set. And then that means you can deploy this into production with some confidence that like, okay, on my realistic hand labeled text test images, this got like 90% accuracy. So I think it's going to probably work all right in production. That kind of engineering piece, where we're actually testing and quantifying something and measuring how well it works before we deploy it, and then we're deploying it in a very systematic way and removing the opportunities for something to go wrong. That's what we're going to be bringing to this type of thing. So just starting with image classification, we're going to be doing all sorts of stuff, object detection, this and that. And as more models come out, we have the support and the capabilities, and we're working closely with Qualcomm's teams who understand how these things perform on device, to get them to work. But we're not just targeting Qualcomm hardware. We're targeting anything that has the capability to run these. So that's a good example of the kind of thing that we now have the resources to do. We've got the support, we have the additional expertise as part of Qualcomm around like how to get these models to run quickly on the hardware we care about. It's really exciting.
Awesome. I mean, I come from 20 plus years of embedded, but zero AI. I even knew 10 years ago I should start learning machine learning, but I never got around to it. Now I'm playing catch up. I've got a couple of Edge Impulse Studio accounts, one for work evaluation, one for personal projects. It can be a bit intimidating for a beginner, but I've started from scratch a couple of times. So I guess the question I would ask you is, if you are a beginner you've come from embedded, but not from machine language, what's the quickest path to building your first real Edge AI application? Apart from, of course, buying the special edition of Elektor, just edited by Edge Impulse.
Yeah, awesome question. I mean, and as a beginner, welcome. I think like the thing that's really exciting is that every single person has unique insight into the kind of problems that they face in their area of expertise. And what we need to build is a world where people are coming with this domain expertise and are empowered to build stuff and make their own systems to solve their own problems. So very exciting to see new people entering the space, and that's what we need to make easy. I think there's a ton of resources out there at this point, and it kind of depends where you're coming from. So I'm assuming a lot of people from the Elektor audience are going to be coming from this electronics background, not necessarily ML and AI, increasingly more recently, because it's becoming a more common thing to have exposure to. In that case, there's just tons of resources online. I think we've got like a bunch of content on Coursera There's an Edge AI course, which is teaching you the basics of AI and how it works and how to build models that run on device and what are some of the best practices. Our AI at the Edge book that was written by Jenny Plunkett, who's another engineer at Edge Impulse, and myself. This is kind of meant to be like a big reference book for like, what are all the different moving parts? So, okay, I know the electronics piece, but what are all the algorithms I need to know? And then, or at least need to know about so I can look up. And then what's a good workflow for building a successful project? So if you're starting from zero and want to build a product, what are all the steps you go through to try and maximize your chance of success? Because working with AI and machine learning is a little bit different to normal software engineering. There's this element of like fuzziness and probabilistic stuff, and being able to having to measure performance in a way that is a bit more sort of weird than just measuring like what's the power consumption of my device. In this case, we're measuring how effective is this at is the model at doing the thing that you're supposed to train it on. So there is some stuff to learn there. I think tons of stuff out there are from like the Edge AI Foundation, who this is an organization that got set up by some colleagues of mine right at the beginning of the whole TinyML world, 7 years ago, I think. And at this point is now focused on the broad thing of Edge AI. And they have all these webinars and events and like conferences that they run, which are a mixture of like getting started stuff and also very, very deep like research. So that's fascinating. But I think the best way always to start things is by learning. To learn things is by starting, and just start hacking on something and think about the problem that you have. Try and find other people who are out there who have done something similar, whether it's like identifying something by images, it's detecting something with objects, running a language model on device to make decisions. There's people who have made inroads into this kind of thing already. And what I would recommend is look out in the community, look at what other people are building, try and find some examples and just start building stuff, and then post on our forum. We have a really good Edge Impulse forum, very active. We support it really well. Post in other places, ask people for help. Don't be shy about reaching out, because this is new to everyone, and the knowledge you have about the area that you care about is probably new to the table, and there's so much opportunity to build things no one's ever built before.
Well, there is a lot of support from Edge Impulse. It's not just, read the 640-page data sheet. You'll find what you need in there. You mentioned the forum. There's the forum, but also I'd like to note your tutorial section is very comprehensive. A lot of companies don't put this much effort into it. I mean, look at the sections here. You've got audio, keyword spotting, sound recognition, time series, motion recognition, data ingestion, generation, annotation, feature extraction, machine learning, inference, post-processing, all of this tutorial. So there is a lot of stuff online for you. Daniel, do you know what the impetus was for being this thorough with your documentation tutorials?
Yeah, I mean, it's really part of the DNA of our company, and I'm really happy that you noticed that. I think it just comes from the background of our founders. So Zach and Jan, who founded the company, they both came from ARM, and they'd both been working a lot in developer relations, which is basically the sort of art and science of making things accessible to developers and helping people understand how to do stuff with your technology product. And they both knew from the beginning that DevRel is like, 70% of the challenge of building a product that people can use, because it doesn't matter how good your tool is if it's not easy for people to get onboarded and understand what to do and feel supported. And, we like to treat our customers, even if it's a user who's just using our product for free, just comes to the forum, asks a question, we want them to feel as important to us as the biggest business, because those are the people that you have to nurture, who are going to become big customers someday in the future, or they're going to go out there and build the next amazing thing, or they're going to do a tutorial about our product online that's going to draw loads of viewers. So everyone's so important to us, and we really want it to be as easy as possible to get involved with building with this technology and with Edge Impulse. So That's something that we've really maintained as we've grown, and we're now bringing that to Qualcomm. So a big part of why Qualcomm was excited about having us join the fold is because Qualcomm's typically been selling to big giant companies, and they haven't had to worry about this stuff too much. But with the IoT, all this problem solving, it's happening by domain experts, out there in the field. And we need to make Qualcomm's entire stack, their whole IoT and AI stack, accessible to everybody. So this is something that we're really going to be, along with Arduino, bringing that DNA into Qualcomm and helping teach Qualcomm how to make accessible, friendly resources and support developers in the best way possible.
Great. It's great when there's no shortage of help, and easy help, not like I said, 640-page data sheet. I'll move now to audience questions. Now, we spoke earlier about emergent behavior, or as I learned in grade 8, a system is a body of parts working together for the functioning of the whole. So that brings me to Jens Nickel. He's our editor-in-chief. He has a question. Do you see a big future in IoT for different controllers running different models and working together? For example, one machine vision, one for environmental sensor fusion, and another controller that combines all the results, also using Edge AI.
Yeah, 100%. That's such a great question, because it's easy to talk about these things without thinking about okay, what is the architecture of how this actually works inside? But a good example of this, imagine you have a device that's got to be seeing things out in the world, making sense of them, making a decision. So let's say we've got this doorbell, which is deciding okay, is someone at the door? We've maybe got one model that's got a person detector that's working with the camera input. The picture comes in from the camera. The model tells you, okay, there's a person and this is where they are in the picture. And so what we might want to know from the doorbell is someone dropping off a package, or are they actually waiting at the front door for me to come and answer the door? And that's very useful for me to know. I don't want to be rude and have somebody waiting at my front door because I'm preoccupied with something. So let's have a second model that can then take the time series of where that box is, of where the person is, and tell you, classify that into either someone delivering a package. So maybe the box comes in quickly, moves down as they drop the package, and then leaves again, versus someone who's coming in and hanging out and waiting, and maybe just moving around a bit as they kind of hang out there. That's something that you take that time series of the way the box is moving and feed that into a second model that makes that decision. And now you've got this magic doorbell that can tell you, is there someone waiting or are they delivering a package? I got a notification this morning saying that there was an animal outside and my neighbor's cat was wandering around. So these are things that are out there right now. That's a very easy example, but then what if you've got a vehicle, a self-driving vehicle? This is literally how they work. So they've got models that are taking the sensor input and using that to create a big kind of 3D model of the world, but it's not just raw 3D LiDAR data. It's been decomposed and kind of inferred into this is where the people are, this is where the other cars are, this is where the lines are in the road. And then you've got maybe another model which is taking in traffic information, and then all these are kind of coming together in a big model that's taking them as input and deciding what is the car going to do, and are we going to turn or put the brakes on. So yeah, this is exactly how that stuff works.
Awesome. Jens, I hope that answers your question. And I agree with Michael Walker on YouTube, who says fascinating stuff. And Voter has a question. Do you already know new AI applications that can be created or improved with Edge Impulse?
Ooh, this is an interesting topic. I mean, I hope I kind of been drilling in over the course of this webinar is there's so many experts out there in the world in these niche fields where in the past we kind of depend on a company to come along and build a product for us, or you've got these big companies that develop solutions for different kinds of problems. Like a self-driving car is an obvious one because there's everyone likes being driven around. So it makes a lot of economic sense for a company to come and build a self-driving car because there's a big market. But there are some things where it's only actually relevant in one factory or one shop or one home. Like imagine you've got a factory making something that no one else makes, and you're using a process that has been, developed in-house over decades by your engineers. You're not going to have a company come and just happen to build a product that works exactly for you off the shelf. So what we want to do is allow these domain experts, the people working at your factory, to have easy tools to be able to build a solution that works just for your specific use case. And there are so many out there that it's like impossible to list, right? Like every single little business out there has these kind of applications. And there's stuff you could even build within your own home if you're a hobbyist that is unique to your family or your house or your pets. So I'd encourage people to think like literally everything that you can think of, there's something that you could build really. And the more of a niche expert you are in your field, the more opportunity there is for things that you know how to do that no one else does. But broadly, I think like with Edge Impulse, what we're seeing is a lot of stuff in industry, monitoring production lines, visual inspection, understanding are these things being manufactured correctly or not? Is there a safety risk here? We're seeing loads of things with wearables. So we've got different kinds of like smartwatches or headbands or sensors for either fitness stuff, like how well am I doing at weightlifting? Reading EEG data. So like, how well am I concentrating? Am I sleeping well or falling asleep easily? Or like, even like, can I like control the computer using my mind? We have people building stuff like that. There's health stuff. So like tracking and monitoring health conditions and understanding and interpreting data from equipment in hospitals. So these areas I think are really important. And then also human computer interaction. So like, how do we understand what someone needs when they're using a physical product? Can we do like wake words, like keyword spotting, understanding when someone's asking for something, understanding when someone's having trouble with a product. So those are really good areas to think about if you're trying to find an idea in this space.
Nice.
Good question.
Great stuff, as the YouTube viewer calls on 9286 says. We've got about 2 minutes left. Are you okay if we go a couple minutes over?
Of course, yeah, absolutely.
Great. So I've got a question from Vinicio. Do you think this ecosystem of edge devices could be the starting point for a parallel network to share data?
Ooh, that's a really good question. I would like to think so. I think the challenge we have in this space, and this was even true when I was working in like agricultural technology like a decade ago, there's all this potential to build stuff that benefits everybody with data that we pool as organizations, as individuals, as companies. But as an individual, obviously, I don't want to share all of my data. I have a certain sense of privacy. I don't want to share my entire life on the internet for people to build products with. Similarly, businesses also don't necessarily want to share their data. So, for example, I've worked with farmers who they know how the crops are performing in their different fields and how much fertilizer they're putting in, and you can use that to kind of understand like, oh, how can I save money by not putting as much fertilizer in the places that don't need it? To build ML models that help with that, the best thing would be if all the farmers in the world pooled their data, and we have this giant data set of soil types and fertilizer needs and crops that grow well there and this and that. The problem is, for an individual agricultural producer, that's their secret sauce. That's the thing they and maybe their parents and their grandparents have been figuring out, is how do I do the right stuff on this land to maximize how much I'm producing? So they don't necessarily want to share that with their neighbor who they're competing with in the market. So that's the challenge we have here still in all of industry. It's like these companies want to be able to improve the efficiency of what they're doing, but also they have this fear of like, if I give this, it's giving my neighbor an advantage. So what we've got to do is figure out some kind of organizations that go across and provide this net benefit to everyone in a way that people can feel comfortable sharing data with and being a part of. This is if we're going across organizations, and that will be very helpful because it kind of breaks the economies of scale that you get from this consolidation where all the factories are owned by one company, all the farms are owned by one company, which kind of sucks. So there are cool organizations out there doing things like that, like ML Commons is a good one. So they are basically building data sets that are good for advancing the state of the art with machine learning and AI. And they particularly care about edge AI. But it's a very big challenge because there's a lot of difficulty in getting people to share data. So if this is something that people are interested in, I'd encourage you to like join in and help organizations like ML Commons. If you're just within one organization and you're building an ecosystem of edge devices within your company, and you have this network that you're creating, then yeah, pulling data for your own organization is also a really good idea. So you never know what you're going to need data for. So if you have the opportunity to collect it, it can be helpful in the future. So err on the side of that, and you might be able to do some interesting experiments.
Yeah, I've seen people delete data. Why do you need this 20-year database of crap, basically? But now the AI can dig through it so efficiently that you might regret deleting your data.
That's such a good point, actually, because we have had this situation where we've all been told data is the new oil or the new gold or whatever for like decades now, but until recently, there hasn't been much you can really do with it. And a lot of the problem is because you can capture the data, but like it's been too costly to send it to the cloud and do inference on it. But now we can do inference on the edge. You can actually train models with that data and then do the inference on the edge. So the data is actually useful. And then we have these big AI models that are coming out, which can potentially help you labeling that data. So when I was talking about the camera traps, one of the tricks these researchers use to train the models is they've got a big unlabeled data set from the old school camera traps where it would be really expensive to have someone go in and label. But what's cheap is feeding that into a big AI model and having that label them. And then you use that data set to train a smaller model, which can go on the device. So the big model would never fit on the device, so you can't use it. Small model can. You do the labeling with the big model, train it on there. We have tools for doing that in Edge Impulse, by the way. So if you've got a big pool of data sitting around, maybe now's the time to tap into it and build something.
Awesome. And compliment from CJ. Excellent conversation. Thanks, CJ. I happen to agree. Prakash asks a question which looks like it could take you half an hour to answer. We don't have that kind of time, but what are the complexity of the models supported currently? For example, MobiNet, DSCNNs, ResNets, transformers, mixers, LLMs.
Yeah, great question. The way to think about this, I think, is if you think of like the spectrum of devices from like really small, low power, like 8-bit microcontrollers, all the way up to a like a GPU in a box sitting on the edge, which, that is an edge device now. This is embedded hardware that we have now. It's like boxes with big GPUs running in them. So across that line, obviously the big stuff supports everything. I think where you start to see a cutoff point is like not necessarily that the model can't run the architecture mathematically, because these models are made of different operators, and those are the mathematical operations that are happening in the network to do the magic. Most of those are supported down even to pretty small targets at this point. They're going to be optimized and will run really fast on the bigger targets. They might not be so optimized on the middle and smaller targets. And the reason is that some of these things like transformers, for example, those are mostly useful on bigger models. Like transformers are really helpful in being able to train really gigantic models. That's part of why we use those. So inherently, like a really tiny model probably isn't going to have that much benefit from using transformers. So we don't tend to see as many at that size, even if the hardware is capable of doing the underlying math. So I would say, the smallest devices, they can all run CNNs and stuff like that. But you're not going to probably be doing much image processing on a really low power, tiny, cheap throwaway microcontroller. Mid-range and to like top end microcontrollers, you're going to be running pretty much anything you want. It might not run super fast, but in terms of these convolutional models, mobile net, yeah, absolutely, running real time on a mid-range or high-end microcontroller for sure. Maybe even run a few of them at once. You've then got, as you get bigger, like, yeah, you can still run the big mobile nets, but maybe you can also run vision language models on these sort of like upper mid-range targets. And then the big GPU boxes, those are running production deep learning, generative AI models that you would get in the cloud. So hopefully that helps.
It definitely helps, and I'm glad you managed to make it so succinct, given that we've gone over the hour. I'm afraid the audience is still asking questions, but we do have to move on. I'll give you another compliment, Daniel and Brian. Thanks a lot for this very good webinar. Thank you, Jens, for joining us.
Yeah, thank you so much. I would say, actually, if people still have questions, feel free to drop me an email, daniel@edgeimpulse.com. I'll definitely reply. Apologies if I'm slow, but always really exciting to hear from people. And also, if you have specific questions about Edge Impulse, the forum's the best place to go, because we have people monitoring that all the time, and the community is also really active.
Okay, I've dropped your email in the chat, so there if you want to reach out to Daniel. And then I will wrap it up with a forward-looking question. If we fast forward 2 years, what physical AI capabilities do you think will feel totally normal? The things we'll forget were impossible in 2025?
Oh, such a good question. I mean, I think there's going to be like a generation of products soon that are kind of mixing the Gen AI on device with the sensor perception on device. The one thing that I'm really kind of curious about is, like, what does that mean for like entertainment? And this, I'm sure like Qualcomm would like me to give this long thing about like how it's going to transform industry and things like that. I do think like having this intelligence embedded in like industrial plants, for example, is gonna do interesting things. I'm not a domain expert there, but I do know I like cute things. And there's things like this toy that's from Casio that came out recently. It's called a Mofflin, and it's basically like it's kind of like a guinea pig. And it has some ML models in there doing various things. I'm not even sure what, but it's basically just this like little friendly pet that it's got enough intelligence that it feels like a real pet. It kind of recognizes me when I come in the room through my voice.
Cool.
It can understand like when you're paying it attention or when you're ignoring it. I think we're going to see loads of weird and wonderful new inventions and things like that are just like, this is an experience you couldn't really have before. I feel like often it's the like creative and entertainment stuff that leads adoption of new technologies and really shows what you can do with it before it gets into the like totally transformative serious business. So if we're talking 2 years time, I think we're going to see some really, really cool things. Like if you go walk around one of the trade shows like NVIDIA GTC, there's so many robots walking around, like little friendly, cute robots that you can have, interaction with, and it's kind of mind-blowing. So I think we'll see more of those walking around in public places in the next couple of years.
Awesome. And it's almost Christmas now. I'm going to look one of those up.
Yeah, awesome.
Very cool. Dan, thanks for the brilliant conversation. And thanks to everyone watching. I'd like to remind you that the Elektor Mag Special Edition, guest edited by Edge Impulse, is out. And of course, we're giving away 5 of those if you go to our entry form and enter the word Impulse. Somebody said the form wasn't working. I did try it. It worked for me, as it did for another colleague of mine. So I'm not sure what the problem was there. But yeah, it's out. It's here. It's full of content. So please do enjoy it. And thanks to everyone for joining us from around the world. Dan, you are still getting compliments coming in, so I'm trying to get them on the screen.
Well, thank you to everyone who joined. And yeah, thank you so much, Brian, as well. This has been a really awesome chat. If you're curious about this stuff, go out, grab an Arduino Q. fire up Edge Impulse and start building some stuff. Send me an email and show me what you built.
Yeah, maybe I'll show you what I can do. Probably
Yeah.
not much, but there's your Arduino queue. Anyway, thank you, Dan. Thanks again for joining us. I hope you have a great rest of the day.
Yeah, thank you so much. And yeah, happy holidays, everybody. And yeah, enjoy building some cool stuff.
You too. And thanks to the audience from around the world. Good luck to those of you who are going to enter the competition. Just as a reminder, next week on the 18th, we have our final Elektor Lab Talk of the year, where Jens will join me, and we will do a wrap-up of the year and see what the latest projects and what we're working on are. Other than that, have a great time wherever you are in the world. Goodbye.
Bye-bye.